Hey. Real quick, just some announcements. I want to get started. Please email me if you have any questions. Be on the live stream. Another thing is I want to make sure you are completing the whole lesson because it does count as credit. A lot of students are not completing the whole lesson. So this week, we are not doing exit slips on Google Classroom. It will be all on Peer Deck. Your exit slip and your whole lesson will count as your 5 points formative. So please make sure you complete all the slides. I am up to date on my grades. So your quizzes went in over on Monday. Make sure that you check your grade because I will be releasing for makeups pretty soon. Those are going to come up in the next week. All right. Today, we're going to review some problems based on this objective. You're going to be able to apply and understand the rules of exponents by simplifying exponential expressions. One thing I want to hit on, you are simplifying exponential expressions. What you're going to do is you're going to look at all the rules you've learned and how can you make it the simplest form. It's almost like PIMDAs. You're looking to see what applies. To prove that you understand this, you are going to earn 5 points formative by completing this whole lesson with a passing grade. This whole video is on recaps from last lesson. One of the things that I noticed right here is I want to go ahead and highlight how you explain the quotient law. Well, if your explanation said that you're using the rule that you're subtracting the exponents, well, in this case, if you look here, you can subtract each one because 7 divided by 7 is 1. 11 divided by 11 is 1. So if you have the same numbers, you can subtract them. In this case, this is what I'm subtracting, and this is what I'm left with. Because I'm left with this is my final answer. So I simplified the expression using the quotient of exponents. Okay? Well, in this case, of course, we're dividing. So that kind of gives you the idea there. Next one, let's go ahead and simplify. Okay, next one. You were given these two problems as an exit slip. We're going to go ahead and analyze each problem. For this one, it says select all that apply. Obviously, letting us know there's more than one. You're going to simplify the expression as 8 over negative 12. Well, looking at A, it does not apply because 8 to the positive 12 is not the same. Well, this one here, don't forget, this distributes to each one. Well, 1 to the 6 is going to come out as 1 because 1 to any power is going to be 1. And then here we have 6 times 2, which will give us 12. But notice, since this is at the bottom, it will be negative 12, so that one does apply. This one here, same thing. You're going to distribute using power to power. 6 times negative 2 will give me negative 12. And then what you're going to do is you are going to multiply and you get that negative 12. This one here, when I distribute the 3 to the negative 5, I'm going to get negative 15. So that does not equal negative 12. These are not the same. Here, 12 to the 8, still not the same. I'm going to distribute. And remember, when something's at the bottom, it means negative. So 1 to the 4th, any power is going to be 1. Because 1 times 1 times 1 times 1 times 1, and so on, is going to be 1. But when I multiply here, 3 times 4, this 3 is actually negative because it's at the bottom of the fraction. Remember that negative law. So in this case, it is 12. So that is equal to 8 to the negative 12. Because if we took this out, it would equal 8 to the negative 12. Next one. Now here, we got to really think of what we can place in each box so it is a true, so the equation's true. Well, here I got to think of what would equal 0. As long as you do a 0 pair, they are the opposite of each other, it will work. So 3 and negative 3 would work. 1 and negative 1 will work. 20 and negative 20. As long as you have a 0 pair, they are the opposite. It would equal 0. Okay, this one here, we have 4 to the second, and then here, we want to know what that equals. Well, you could put any numbers as long as you know what will go and make it. So you have to pick numbers bigger than the top so that your answer is negative. In this case, if I pick 6, it's going to be negative 4 because of what's left. If I put 8, it'd be negative 6. As long as you're showing that this is coming out to here. Okay? So really backwards thinking. What is the rule? What am I trying to get? So here, I have 30 to the blank. Well, what is the rule and what am I trying to get? Well, if you look at this, you can what do you multiply to make 30? In this case, I will multiply 5 to make 30. But since these are different bases, because this comes out, you don't see a 6, you see a different base. Well, that means my exponent is going to stay the same. Because different bases, you multiply, but if it has the same exponent, you can keep the exponent. This is kind of hard to see, but that says negative 4. So just again, thinking about what is my outcome, what rules apply, and what numbers can satisfy that outcome.